first part. So as you can see me in the image, so this is the second part for the aero engine. First you are seeing in Russian aircraft, second you are seeing the aero engine. This is a critical part of our country's one of the engine. We have successfully printed using the laser powder bed fusion technology. Wipro 3D is a company who has helped us to develop this part. This is the first certified parts flying in our aero engine, critical parts. Then in 2020-22, we have ventured into the transport aircraft. Transport aircrafts are operated by Indian Armed Forces to rescue people when in any calamity situations, or when we have a civil war in some places where we want to rescue our country people, we will send our civil transport aircraft and bring them back. Or when you wanted to send some medical aids, we use a transport aircraft. So transport aircraft plays a crucial role in our armed forces wing to support civilians. So one of our transport aircraft, these complex parts were used. Earlier it was manufactured through again casting process, and we have reinvented the wheel or reinvented the component using the 3D printing, again with the help support from Wipro 3D, because this is the first firm in the Asia, not in India, Asia, who has got the NADCAP certification, widely acknowledged by aircraft OEMs across the globe. And as I said earlier, it gives the edge of about 60% or 40 to 60%. So I give a part which is better than the earlier manufactured process part. I mean, my safety margin or factor of safety is much higher in additive manufacturing. So that's the advantage. People or the designers have agreed to adopt this technology in the most critical scenario, that is the aircraft. Because aircraft is the aircraft and nuclear industry are the very critical technology intensive industries, because in the aircraft need to prove the parts for about 7,000 hours is the total life of the aircraft. Unlike ISRO space, it's a one-time flying. So if I have a part, okay, I can put it in this spacecraft because I don't need the reliability. One attempt reliability is sufficient for them. That's why you often see ISRO's rocket launch, and you don't see the Indian military aircrafts development not in that same pace like ISRO. So we have done on military aircraft, we have done on transport aircraft, we have done the fit the part in aero engine. And so that's where the thought process evolved. So we are having a kind of a maturity in the part development. But as a country, what we have to see, the entire ecosystem development in the country. So with that mission or the vision in my mind, I have initiated the development of entire AM ecosystem in our country, so that we will be self-reliant, self-sufficient, and we don't face any technology denial from the countries, especially the developed countries. So presently, you would have seen the Trump impact on our country's products, especially in the tariff point of view. You can see that the kind, when the situation comes, even a friend becomes enemy in an international political situation. So such a kind of scenario, we have to create the highly sophisticated defensive system so that no one can dictate us. I mean, we will be more powerful and stronger. We will not get budged by any foreign powers. So in order to achieve that mission, so I have started the mission of creating the AM ecosystem in the country. So part we have done. Now, if you look at the ecosystem, I need the raw material, either powder or the wire. Then I need a machine. Then I need a part. Then I need a testing units. So this constitute the entire ecosystem for additive manufacturing. In the mission, the third one, which is very important, crucial at that point of time, was a part manufacturing, which we have done it. So I have initiated the powder development with the Indian company called Indo-MIM at Bangalore. This is the first powder, high temperature material called Inconel solvent. Mechanical engineers may understand. Others don't worry about it. It's used in the nuclear industry or the aero industry and space industry, widely used high temperature material. And this is the first powder, in fact, in the Asia, developed indigenously in India, certified by us. And in fact, this is getting qualified in Indian made machine, not the abroad made machine. And This journey started in 2019. So far in 2025, this is the 23 letter which I got appreciation from Indian Armed Forces. Group Captain Praveen has sent me the appreciation to me because as a scientist from DRDO and supported their uh, fleet requirements, mainly the part development, MRO, maintenance, repair, overall parts development requirements. About presently about 198 parts are printed and successfully flying in our different fleets, military fleets. Since I have set up the center of excellence for them in their armed forces at Nasik, plus subsequently I have been mentoring them till today, the center of excellence and coming up with the different parts and different configuration for them. So it's gratitude from that side to give me the appreciation letters. It's 23 appreciation letter I put. Actually, I got 24 also, so I cannot put it due to the time. I didn't get the time to replace this. So, but the bottom line is like, we are matured in the technology to bring the parts, successfully qualify and fit it in the aircraft and fly. So that is the state we are. And I think when Dr. Dhanapal was reading the profile, so he talked about the ASTM Singapore. So among the Asian countries, we are the first one to establish the MOU with the ASTM Singapore. People who are from Andhra Pradesh can identify the person who is standing there. He's Telangana former IT minister, Mr. K.T. Rao. So in presence of him, we have established or we have released this MOU with ASTM Singapore. My friend Dr. Liu is there on the right side. So he's the one from the ASTM representative and my seniors in this side. So this is the first ever activity in the additive manufacturing happened in the country way before academicians or any other organization in the country started. It happened in 2020-22. So we didn't stop there since we are into the aircrafts. One is the metal system, another one is the composite system. So these are the two systems that are widely used, especially in the airframes. And our country's Tejas aircraft totally rely on composite materials, mainly polymer matrix composite. So understanding this need, I have spoken to NIT Trichy, one of my good friend, Dr. Durai Selvam. I think most of you know him. He is in production department. And my senior friend from IIT Madras, Dr. Jayakantan, where I got graduated. I spoke to them, why don't you help us, developing the machine, mainly for the polymer matrix composites. So they have gracefully agreed and I have initiated a project with my other friend from DRDO, that is DRDO, Dr. John. So we have sanctioned them 2 crore rupees to them to develop a mission for the polymer matrix composites to cater for aircraft structures and missile structures. So currently the proof of concept is under progress. So we didn't stop there. Now powder is done and part is done to help the entire ecosystem. MOU is done and novel materials which are niche material needed for the aircraft and missile structure is under progress. But one of the biggest challenge what we face is, the properties, lack of properties, because it has not gone through the conventional way of academic research and data development and standard development, then goes to the commercialization. Actually, it is commercialized way before the standards and properties are available. So it is imperative for the academicians, like it is their responsibility to serve our country by researching on property development of additively manufactured materials. It's like how US does. They have a document called MMPDS, Metallic Materials Properties Development Standards. So they call it. Similarly, we also have to develop. So I urge all the faculties who are attending or interested in additive manufacturing, rather than working on some weird things which are not useful to the country, please work on the material which are used by the industry. Try to develop various data. Don't focus only on tensile property. Focus on variety of properties. And in the mission of the entire infrastructure development in the country, the testing is the another lacuna, I would say, like the weakness in our country, because we don't have a sufficient testing missions, especially the long cycle testing like fatigue and creep. So this is one of the bottleneck for additive manufacturing penetration in our country, because all these additive manufacturing company in the India, all of them are either MSME or startup. Very few companies are top big companies. In fact, Wipro is also, I would say, it's a small scale company industry, since I know them very well. So I don't see any medium scale or the large scale industry operating into 3D printing in our country. In fact, in the world also very few. So understanding this, because they will not have sufficient resources, money to invest on testings, there's a thought process which I have given to the Ministry of Defense or DRDO's side, is unifying all these facilities across all the engineering colleges across the country, IITs, NITs, universities, center of excellence, bring all these testing units under one umbrella through MOUs, and help them to get the national accreditation called NABL, so that this can be used by these countries' MSMEs. So in this line, any institutions who has good facilities wants to get support from for this kind of activities, please be in touch with me. I will help you. What is the outcome? What I expect out of this is our country will be strengthened or stronger in terms of synergy generation or the creation between the academia and the industry, and we will make our country self-reliance in this technology. So those are the wings of success from my side for the country, which I wish you all to know, so that you also channelize your research projects in that direction. So everyone talks about additive manufacturing. Why this is very important, or why, where it is more relevant? If you see, most of the research, if you see either aircraft or the space or the biomedical, you find very predominantly, and you never see industries like automobile or other heavy industries adopt additive manufacturing as like aerospace industry or the medical industry. The very reason is these industries needs the number of parts are very less. That's, we call it a minimum order quantity. I need hardly 5 spare or 10 spare or customizable implant of 1 or 2. In those cases, additive manufacturing is the right manufacturing process. When I want the high volume, additive is not meant for the volume production requirement, high volume production requirements. So it helps only the like I need 1 part, 2 parts kind of one-off or the very low volumes. It helps. And everyone knows design freedom, a kind of a complexity I can get through this additive manufacturing, which I cannot realize through the traditional process. So for instance, like mechanical engineers can understand cooling channels in turbines. Biomedical engineers can understand porosity structure for generating the tissues or patient specific implants. And let's say other industries, oil and gas industries, or let's take it to the construction industry, any other industries, heavy industries, where currently I have assembly with 10 or 15 parts. Is it possible to integrate all the parts and make it a single part rather than a single assembly? Is the part consolidation I can do through 3D printing. This all is possible through topology optimization, your design optimization. Then another important advantage what it gives the driver for this additive manufacturing is on-demand manufacturing. Whenever I need, I'll print it. I don't need to stockpile up. I don't need to create the inventory and maintain the supply chain. I just keep the machine. Let's say I need 5 parts, I just print it and directly use it. That's why, in fact, NASA or the European Space Union, they built the they established the additive manufacturing machine in the space. So during the orbit only they'll print it and put it, all these tools, essentials. So there are printers already installed in space. And another area where it can help, especially the high value parts where even a small crack, if I reject it, I will lose a lot of money. Or I run in a turbine, run a turbine for about 1,000 years and crack comes. If I throw it, let's say the only 20% of the life is consumed. If I throw it, I am at lost. So these kind of a scenario, wherever I have a chance to repair and refurbish during the development or the production or after certain hours of use, it is possible. There is a technology in additive manufacturing called DAD. I'll tell you in the next slide what are the different technology in additive manufacturing. And as I said, like complexity, and most importantly, people look at, especially the industries who are into the business, who wants to make money, they look at what is the waste, what is the energy consumptions, what is the lead time. These are the 3 factors. So all these 3 factors additive manufacturing wins, because it has a low buy to fly ratio. Wastage is very, very minimal, yield is very high, lead time is very high, I can prototype quickly, and energy usage is much lower than traditional manufacturing. So you would have come across different terminology in the academic literature. Unfortunately, academicians are not still aligned to the international or the industry conventions. So there is a committee called ASTM F42. This is the committee responsible for making the standards and specification in additive manufacturing. They classify the process name accordingly. If you are using metal to make any parts, irrespective of the industry, they call it powder bed fusion. If you use the powder as a raw material, and you can use a laser as an energy or electron beam as an energy. You can call it laser powder bed fusion or electron beam additive powder bed fusion. Suppose a very high value parts, I want to make it like a bigger size parts, then people naturally go for DED, direct energy deposition. Again, I can use a laser, or you can customize your welding machine. You can use a plasma arc or electric arc. Big size parts, relatively inferior property compared to laser powder bed fusion, or relatively lower control over the compared to the powder bed fusion. Okay. So these are the two prominent technology identified or classified by the international practitioners. Then comes the polymer. So most of you know about FDM, fused deposition modeling, or fused filament fabrication they call it. Apart from that, you have stereolithography, liquid digital light processing, material jetting, laminate object manufacturing. So you can see here, fused deposition modeling is the most widely used in the polymer, and second will be this SLA, that is stereolithography or direct light processing. Then when it comes to the ceramics, there is only process available to prepare the ceramic parts is called binder jetting, where you use the binder to glue the ceramic particles, make a shape, then sinter it. During the sintering, debinding will happen, all the binders will get removed, part will be consolidated. This is simple things. And of course, people who are into the industry of biomedical, they use the bio printers. These are not classified in this so far. But in the biomedical printers, you have a bio inks usually. The ink will be injected and your shape is made. And people who are from civil engineering, they use the extrusion based printers for the construction industry. That's all is the ecosystem in the 3D printing. So let's understand different sectors and what technologies are used. Look at the left side of the slides. You come across one name called laser powder bed fusion. This is the most widely used technology. Commercially, 95% of machines available in the country in the metal are laser powder bed fusion. So if you want to make your biomedical implants, LPBF, or if it's a titanium implants, people go for electron beam additive manufacturing. That is because of titanium has high reactivity. And any aero sector or space sector or defense sector, if a part is small, people go for laser powder bed fusion. If part is so big, like 2 meters, 1 meter, people go for wire arc additive manufacturing. And same thing goes for oil and gas industries, energy sectors, railways. Only these two technology rules, laser powder bed fusion or RAM. When it comes to the automobile, there are some plastic parts are there. There the people go for FDM, fused deposition modeling. Metal parts are again laser powder bed fusion. Automobile industry, again, it's not the it's not the like your Maruti Suzuki or kind of a low end cars. Only the luxury cars or sports cars only people the industry adopt additive manufacturing to get the niche parts, niche shapes or niche some specific advantages. So sports industry and another industry called tools and die making industries, they also use laser powder bed fusion for making the dies or molds, or to repair dies or molds, they use a laser metal deposition, which is a DED process, direct energy deposition process. In fact, in the coating industry, again, laser metal deposition rules. Anything coating, thermal spray to other kind of deposition you want to do it on any substrate, people go for LMD process. This is one chunk of the sector, which is more of a high intensive business oriented. There is another sector which we don't come across in engineering, very minimal. That is the jewelry industry or the art and design industry. In these industries, if I want to make a mold, either through polymer or ceramic. I go for stereolithography or digital light processing. If it is ceramic, binder jetting. These are the processes are used in the this sector which we are not very much exposed to. And people who are from the electronics industry, you would have come across material jetting and aerosol jetting. Aerosol jetting is the most famously used technology to print the circuit boards substrates. And in fact, many would have seen those are made through 3D printing. Food industries or confectionaries, sweets are made through 3D printing. So all use like your FDM technology kind of extrusion based. Consumer goods, like you want to make a statue, you want to make some sculptures, any other products, toys. So you can people use the low cost technology like FDM or multi jet fusion technology to create the different colors and all. And the recent uh, industry which adopted additive manufacturing is the construction industry. In fact, highest altitude, Indian Hyderabad company with IIT Hyderabad, they built a machine which was built a bunker for our Indian army. This is the bunker which was built by 3D printer, located in highest altitude in the earth, is in our country, and done by our Hyderabad people. Hyderabad firm with I'm associated with IIT Hyderabad support. They built for Indian army. So again, here the technology is like a food industry, extrusion based only. Okay. So now let's look at in each sector what research we can do. Because I don't want to cover only for biomedical or only for the aero sector where I have worked. I want you to understand the entire sectors, then you decide what interests you. So before getting into that, you have to understand where this additive manufacturing can be used. You cannot print the entire aeroplane or entire automobile car through 3D printing. So where it is used, if you see, and what kind of material is used, we will look at it. If you look at the automobile industry, wherever I can do the rapid prototyping, or wherever I have a high-end luxury cars like BMW, Honda, or Rolls-Royce kind of a cars, where certain niche parts they use it, either polymer-based or the metal-based 3D printing. Okay. And ceramic 3D printing is widely popular in construction industries to make the bricks, because their bricks or panels, all of them are ceramic materials. When it comes to the medical industry, anything of support like medical support, splints, models, biocompatible ones, people use the polymer 3D printing. Anything implants you put inside the body, like a titanium implants or stainless steel, people use the metal. Anything of the dental related or the scaffold related, people use the ceramic. And when it comes to the easy electronics area, anything of the printed circuit substrates or high temperature insulators, sensors, people use 3D printing these days. In the energy industry, only 3 applications where 3D printing is deployed or employed extensively is to make the complex shaped parts like pumps, valves, heat exchangers. And in the consumer industry, high value customized wearable area, people use the 3D printing, mainly the polymer based. And the aerospace sector, in fact, entire rocket engine you can print it, not the aero engine, rocket engine. In fact, in our country, there's a startup called Agnikul, which is located inside IIT Madras. I have been interacting with them. They are the first one who printed the rocket, and which is successfully launched very recently. And the aero industry, especially the coating area, thermal barrier coating, ceramic coatings, so thermal yttrium stabilized zirconia, which I have talked about in the last functional reliability. So that can be printed through ceramic 3D printers. Food industries, mainly the sweets, confectionaries, can be 3D printed. Jewelry industries, high value metals like gold, platinum, titanium, these are 3D printed through the metal printers. Art and design industries, porcelain sculptures, like you have a very beautiful glass on that, you want to make some sculptures, that kind of artwork or design works, ceramic printers are used. I also wish you to know what is the size of the parts I can make. I mean metal or polymer or concrete or ceramic, and who is the leading player in the market, either globally or in the India. See, if you're going for additive manufacturing, metal based one, powder based one, maximum size of the part what you can make is 400 by 400 by 400. That is the biggest machine commercially available in the country, in fact in the world, I would say. Because world I cannot comment because I don't know about the Chinese and other markets, but India I can certainly say, since I am uh, well connected with all this additive manufacturing in the country, because I have been mentoring many companies. Coming to the polymer, about 1 meter, Stratasys is the company who is the market leader in metal, LPBF, EOS. Similarly, concrete, what I talked about in 3D printers, about 3 meters on the height. There's a company called GoBot. They are the global leader in India. Vasta, there is a company, T Vasta Manufacturing. In ceramic 3D printer, very few players are there in the market, and size also much smaller, about 150 mm. Mainly used for dental crowns and other, to make those kind of a bio implants. These ceramic printers are used. Litho is the famous company who makes the ceramic 3D printers. And in India, last 2 years, we have indigenous players. There's a company in Bangalore called Intech, Amaze. They make the 3D printers, it's metal-based one, either powder-based, powder bed fusion based. Polymer area, there are many players, but Divide by Zero is the leading guy in the polymer 3D printing in India. And I know a couple of youngsters who started the startup and doing really well in Bangalore. It's a company called Fractals. Fractal Works. They do make 3D printers according to the academic needs. And concrete, I told you, ceramics, we don't have any player in the India. So this will give you idea about what is the size you can make the parts in the with respect to the different additive manufacturing process. There are some bio people who are sitting over here. For them, with respect to the bio printers, there is a company called CellLink. There's a company called Region. So these and CellLink and Region are the global player. In India, there's a company called Inventia and Bio Plus. The percentage what I have given is their market share, and their machines are mainly based on either extrusion or the inkjet printing. That's all. Or the hybrid of these two. And maximum size of the printer is about 300 mm. Reliable 300 by 300 by 200 is the build volume. And the material, biomaterial, what they can print are hydrogels, bioinks, or anything, cell laden polymers, collagens, gelatin, PCL. These kind of materials are easily 3D printable through using the bio printers. Since the talk is for 3D printing for the bio or medical implants, biomedical, so I just wanted to initially start with the research focus on bioprinting. Then I'll give you a 2-3 minutes break for you to post questions in chat box, so that I will drive my talk in that direction. And I suppose I should complete by 7:30. I'll try to complete by 7:20 so that I'll have 10 minutes for the discussion. This is one of the feedback what I said last time. So if you are interested in bioprinting, multi-material, hybrid-based printer development, which can do the job of cells with scaffolds with the growth factors, combinations. How cells you can make it to grow on the scaffolds, and look at that prospect of that for the bio industries. Second will be vascularized tissue or the organ fabrications. This is the second important research area which is happening in bio sector. Third will be generating or creating the bioinks, which is a stem cell based, so that can be used in the regenerative medicines. And printing the functional organ models for testing the drugs, or for the personalized medicine area. And fifth will be electronics can understand how to integrate sensor for real-time monitoring of our cell viabilities. See, these are all said and done, these 5 important areas where you can research. What are the challenges, the grown challenge reality what we face in 3D printing or the bioprinting area? Maintaining the cell viability while I print it, and creating the highly complex geometries with a good resolutions, and input material like a bioink, developing that with the proper rheological flow properties and the mechanical properties. These are the impending challenge in the bioprinting. And of course, anything biological which is dealing with the human beings, ethical and regulatory issues are, without say, is the biggest challenge. And scalability issues, how from the lab to the market, that is clinically relevant sizes, is the another biggest challenge. So people who are interested in startup, look at the last two aspects. People who are interested in only lab scale work, look at the top five work. Right. So another set of people who are there in the today talk, they may be from civil engineering. For them, if you're interested in implementing 3D printing in your civil engineering, that is a concrete 3D printing area, what are the areas you can work on? One is on the basic material, that is the raw material, concrete or mortar. What mixing ratio I should optimize it, mainly for this extrusion based printers. Second important thing is how I will do away with this concrete and mortar and go for the alternate materials, mainly the geopolymer area or recycled aggregates. So which is I currently throw it off. I can recycle it and reuse it using the extrusion based printers. And there is a new novel concept which is evolving in the construction industry, is modular printing, like block by block. Let's say I have a house with five rooms. Can I make each wall separately and assemble it later? It's to build a biggest size multi-story buildings. Then, of course, in bridges or in mechanical engineering, we put it in the aircraft or the space. We integrate the sensor and understand the structural health of the structure. Before it fails, I'll detect. I generate the get the data from the sensor. I do the ML and understand, and practice the predictive maintenance. And how to implement robotics, again, this non-circuit branches, they can think of how to, with the electronics, computer science, we can think of how to automate the job of construction industry, so that I'll have a faster on-site printing. In fact, recently I came to know that, like, let's say you build a house, it may take about 6 to 8 months. Let's say every raw material available and human resource available also, you may need about 3 to 4 months. But with the printer, we can achieve that in a week time. So this will be very helpful in a scenario where I wanted to make a multiple houses in a short period of time, or in the for the armies where they want to quickly build the temporary structures where this 3D printing has a high sale. What is the technical issues faced in the concrete 3D printing is the layer adhesions and the integrity of the structures, structural strength. So that how to ensure the quality consistently. So this is one of the biggest problem what they face it. And the other area will be curing, shrinkage, and how to integrate the steel bars, reinforced steel bars or the fibers. This management is the 3D printing. So conventionally you do the concrete and you put the steel bars, and on top of it, on around it you put the concrete and build the structure. But in 3D printing, how to get that kind of in a reinforced structure? So that is another research gray area which you can explore. Please take for 2-3 minutes to feed your questions. I'll just come back. Please feed our questions in this chat box. I'll read and then I'll take another 10-15 minutes to close my presentation, and I'll start answering.
Good evening. I think sir is not in the meeting. No, sir.
Sir, he told that he will come in within 2-3 minutes.
Okay, okay,
Then
okay.
that time
Okay, sir, no problem.
email the candidates can put questions in the chat box.
Yes, sir. Now itself, put it. Then we will read one by one, and sir may answer it, sir.
Yeah. So